In this video, we're going to be learning about systems of equations and by solving them through the graphing method. This is going to correspond to section 5.1 of your textbook. So systems of equations are also called simultaneous equations. And simultaneous equations means that we're solving for two or more variables at the same time. So usually when we were solving equations, we were just solving for x, but now we're going to be doing two or more variables, so we're going to be looking at solving for x and y at the same time. So there are three methods to solving the system of equations or simultaneous equations, and there's graphing, substitution, or elimination. For today's video, we're going to look at this first method here of solving simultaneous or systems of equations by graphing. So let's take a look at our first example. We're going to solve the system by graphing, or we're solving simultaneous equations. So our two equations that we're looking at are y is equal to 2x plus 5 and y is equal to negative 4x minus 1. When we're solving for this one, what we're trying to figure out is where do these two lines intersect. So we're solving for x and y at the same time, and the x and y is going to be a coordinate that we're looking at because it's going to be the point where our two lines intersect. So we'll have two lines and there'll be some sort of intersection, and whatever we get is going to be our answer. So if we take a look at this first equation here, let's do y is equal to negative 4x minus 1. So it's in the slope-intercept form, which makes it a lot nicer for us. We see that negative 1 here is our y-intercept, which means we've got a negative 1 right here. And our slope is negative 4, and we can just say negative 4 over 1. So that means from my point here, I'm going to go down 4 spaces, 1, 2, 3, and 4, and then I'm going to go to the right 1. So I'm going to have a point here at 1 and negative 5. So here's a point right here. Now, it's really important when we're doing simultaneous equations that our line is as perfect as we can possibly make it, because if we do this by graphing and we don't have good lines, we won't see where they intersect properly. So what I'm going to do is, because I've gotten these two dots here, I'm going to figure out what the dots are up on this side so that I can have a more perfect line. If I have 3 dots on my paper, I'm probably going to get a better line than if I just had 2. So if I had to go 4 down and 1 over, I can go 1 to the right and 4 up. So 1 to the right and 1, 2, 3, 4. So my other point is going to be right here. And then I've got a third point and I can't fit any more. So now that I've got 3 points, it's better for me to use my 3 points to draw my straight line, because I'm more likely to find that point of intersection a lot clearer. So here is a line. All right. And then I've got my other equation. I've got 2x plus 5. So my y-intercept here is at 5. So here's my y-intercept. And I notice that my slope is 2 over 1. But the problem with our graph is that I've got the y-intercept here. And if I have to go up to 1, 2, and over 1, I'm running out of space, right? So remember, we can do the opposite to figure out where it will be on this side of the graph paper. So instead of going up 2, I'm going to go down 2 and 1 to the left. So I'm going to go down 1, 2, and 1 over. So I'm going to have a point right here. And then I'm going to just keep going because I want my line more perfect. So I'm going to go down another 2. So going down 1, 2, and over 1, so another point right here. And I've got 3 points, and I can keep going. So I go down 2 over 1, down 2 over 1, down 2 over 1. So I have more points on this graph than I can. But you can already see where this line is going to intersect because the dot that I drew from this red one, or the red line, is going to actually, it went through my equation already. So here I've got another straight line. And I see that the point of intersection, so my answer for this one, was right here. So the solution that we have for this one is we see that the point is at negative 1 and 3. So when we're solving for the simultaneous equation, we have x is equal to negative 1 and y is equal to 3. So you can give your answer like this, or you could give your answer as an ordered pair. So both answers are acceptable for a solution. So here are your first 2 try-it problems for this video. You want to solve the system by graphing, so you're finding where the 2 lines intersect. And you're going to want to do these 2 questions on graph paper because you are drawing straight lines. So use the graph paper that was provided to you guys to figure out these 2 questions. So take a moment to pause the video, graph these 2 lines, and then continue watching. So let's take a look at our second example. We want to solve the system by graphing. So we have two equations and we're going to solve them at the same time. We're trying to figure out what is x and what is y. So we're looking for that ordered pair and we want to find that point of intersection. So if we take a look at our first line here, we've got y is equal to 2x minus 2. This one's really nice because it's in that slope-intercept form. So it's really easy to see that I've got my y-intercept, which is at -1, so -1 is right here. I see that my slope is 2, so 2 over 1, so that means from my y-intercept, I'm going to go up 2, so from here 1, 2, and over 1. So I've got a second point right here, and I'm just going to continue putting in more points so that I have more points that I'm going through, which just improves my accuracy for my straight line. So I've got a straight line going here, and I've got that line, and now I'm going to look at this second line that I have. Now, if we notice on the second line, this one involves a little bit more work because it's not in that slope-intercept form. It's hard for me to tell what is the slope right now and what is the y-intercept. So I'm going to have to do a little bit of rearranging for this equation of a line. So I've got -x plus 2y is equal to -4. The idea is I want to have y on its own because I want it to say y is equal to something. So first, I'm going to have to add x to both sides. And I get 2y is equal to -4 plus x. And now I still don't have y by itself, so I'm going to have to divide this by 2. And I'm going to have to divide each of these by 2. So I'm going to get that this here cancels out. And I get y is equal to -4 divided by 2 gives me -2. And I've got x divided by 2, that's just the same as saying 1/2 x. Now it's not quite in that y-intercept form, but if I notice that I've got this as a term and I have this as a term, so as long as I take the signs in front, I can rearrange that around. So I got y equals to 1 over 2x minus 2. And now it's in the slope intercept form, and now it's really easy for me to see that this -2 here is my y-intercept, and this 1 over 2 is my slope. So for my second line, I have a y-intercept of -2, so right here, and my slope is up 1 over 2. So up 1 over 2, up 1 over 2, up 1 over 2. And this one's nice because I can already see where that point of intersection is going to be because I drew a dot where there was another dot on the other line, but we'll still draw our two lines on our graph paper so that we have it. So I'm just getting a ruler and trying to make sure I'm going through all of my points. And there I go. So now I've got my two lines. I can see now that the point of intersection is right here. So my solution for this one is going to be that I've got 0 and -2. So my solution is 0 and -2. And what this means for if this is the solution is that I can take my answer of 0 and -2 and I can put it into my equations and they'll equal to the same thing on both sides for both equations. So if we just try that out real quick, we see that, use that in blue. So if we do that, we're going to have y instead of y. So if I have this equation, y is equal to 2x minus 2. So instead of y, I'll put in -2 because that's what the y is here, you see. And then I'll have equal to 2, and instead of x, I'm going to have 0 minus 2. And I see that -2 is equal to, on the other side, 0 minus 2. -2 is equal to 0 minus 2, which is -2. Both sides are equal. So we see that 0 and -2 were solutions in this first line. And if we take a look at the second one, so do that one in red. So we had the equation -x plus 2y is equal to -4. So I'm going to make that substitution. Instead of x, I'm going to have 0, so negative, and then 0 plus 2, change the y for -2 is equal to -4. Then I've got -0 is just 0, so 2 times -2, which is -4, equal to -4. Both sides of the equation are the same. So that's what it means when it's a solution, is that we can double check our work with the solution that we get, and then we should be able to plot it into or substitute it into our equation of a line, and both sides are equal. So here are your last two try it questions for this video. Again, you're going to want to use your graph paper to graph your straight lines. And again, we're still finding out where the point of intersection is. So you're just plotting the two lines and figuring out where they intersect. So make sure you complete these 4 questions from this video, and we'll take a look at these in class. See you guys then.